a few slides in this presentation on the first two of these. And our experience so far says our journey in our growth and profit challenge is probably quite similar to yours. So family business, been at it for a while, third generation, and bottom left, or your bottom right, Henry, Charles and Guy now lead the business, and their father and uncle, pictured here in the blue singlet, the blue gilet is John Shropshire, who led the business for 30 years, and he's the one who had the masterstroke of recruiting me to the business. A few fast facts, so 73 years have turned into quite a lot of packs. In terms of investment, we have benefited for probably 20 years from an European Union grant funding programme that equated to a 50-50 matched funding. So if we haven't always been investing at this sort of rate, but let's say over the last 10 years we've invested 35 million, about 16 million of that has come from EU money. So pretty amazing, quite a broad spectrum. In terms of actually getting it, filling in the paperwork is appalling process, and luckily it wasn't left to me to do it because we'd never have got any money. We've got quite a few staff. Vast majority of those are harvesting products, so picking up a lettuce and putting it in a bag, or putting it in a machine that puts it in a bag. So we're vertically integrated. We don't have any seed business. We're interested in getting into seed businesses, but all our own plant raising, all our own harvest and packing, and we do our own marketing, including some branded products, but it's been very hard to get our brand out on the shelves. We have this is our portfolio of products. Most of these we do organically as well, and one of our strategic intent as we go forward into 2030 is that we want to make sure that we are the number 1 or 2 supplier by share in any of the products we major in for any of our customers or any of the markets that we trade in. So in that sense, these are our shares in the UK market, and in particular we've got a very strong share in organics. So this gives us a bit of a scale advantage. It doesn't in any way mean that on any of these products we dictate the price, but it probably means we're a bit stronger in our overall relationship with retailers. So I don't think we make prices. We operate in 5 countries, so a range of locations in the UK and Spain. We've got some sites in Poland and Czech, and then Senegal is we went to Poland and Czech because our biggest UK customer asked us to, as support of their initiative to go trading in those countries. And Senegal exists only to give us 52-week continuity on radish. So we try and do 52 weeks a year from our own resources, but it's not like Australia. We can't do it. We have to change countries to do that. So a range of locations in the UK. Spain locations are possibly more interesting because as we start a season, so when we plant, for example, celery, we start planting celery in July in Spain. So that's about 40, 45 degrees temperature. And we try and mitigate that effect by going up to altitude in Jumia, which is a terrific wine growing area. But we've got some nice land and water up there, so it's a bit cooler. Then we move south into some warmer territory. This is kind of one of the few entirely frost-free areas in Europe, with a south-facing slopes from mountains running down to the Mediterranean Sea, so that gives us some advantage. And then as we go back into the spring and moving towards North European production, we can move the production back north into the mountains. So that's a quick look at what Spain looks like. In particular, this is central to our system. So this is an iceberg rig. All our systems on the salads business are orientated around field harvest and field packing. So we want to have the advantages of handling stuff only once. We want to maximise the yield by being absolutely able to see that we're not wasting it. And we also want the freshness of not having stock in the system. So this material leaves the back of the rig, everything's packed, labelled, pallet labelled, strapped, It goes into a cooler back in the yard, and then it's ready for dispatch. And that's been absolutely essential to our competitiveness. As a philosophy, we want to be recognised as outstanding, and that sets a context for us. So we have to be aware of context when we say that. So in the European context, sustainability matters, and our retail customers have legally mandated targets for the reductions in their greenhouse gas emissions. And 97% of those emissions sit in the supply chain. So we're obliged, in service to our customers, in support of our relationships, and maybe socially, we're obliged to be part of that. And that kind of sets some scene for us. We absolutely believe in producing healthy product, and sustainable arguably means profitable as much as anything else. And we want to be leading edge, not bleeding edge. Where we think of ourselves as being very privileged to have some amazing retail customers that we supply. So broadly speaking, the sort of top row is UK, some processors that we deal with, and then everything else is majority Europe, but also we have a beetroot business in America, so some of them reflect on customers we supply in America. And finally, a quick look at the growth of the business. Here's our progression. I didn't make this slide, but I'm really pleased to point out to you that this is actually as it happens when I joined the business. So I like to think I've demonstrably had a positive effect. I mentioned investments. So we've bought a lot of kit, but a huge issue for us is staffing. So in Spain we depend on. It's a better reflection of a better verb probably reflects the dynamics more. We depend on Moroccan and Ecuadorian labour more than we do on Spanish. In the UK, we use now people from the Stans. Kazakhstan, for example, is now an increasingly big source of labour. So we're this cultural change. We're employing Muslims as opposed to previously Central Europeans. And one interesting observation on that is the Central Europeans come Friday, Saturday, just wanted to drink themselves to the point where they could no longer stand upright. And now that we've got the Muslims, they just smile and stay happy 7 days a week, and they're actually a pleasure to deal with and to have in the business. I probably haven't got time to go through all of those, but I'm happy to discuss those afterwards. And finally then, just to set the scene, I'm guessing some of this may be familiar to you. Basically, our selling price in the bottom has hardly moved, and for much of a recent past you could say it was lower than it was in the past. But our costs have just escalated out of all proportion. So all of us, I think, if this is traditional for a produce farming industry, we've all been fighting against that dynamic perpetually, and there's a variety of things that any of us do to change and stay competitive. And that probably leads me into the wanting to talk about regenerative agriculture and our sustainable farming agenda. Were there any questions on any of that at all? No? There we go. Okay, so why sustainability and into our journey? I've covered some of that. For us, the sustainable farming agenda is exactly what we've got in this box. We're not expecting to make changes which reduce our yields or the reliability of our yields, so Charles Shropshire, one of the third generation leaders in the business, has set the tone with his ambition that the customers never notice the difference. So we're aiming to change what we do without changing any of our risk in the business. But we're absolutely see now that we are able to reduce our purchased inputs. So this is, amongst other things, this is absolutely a profit play. This is not us going soft and green and losing a farming ambition. But we are interested in the fact that we've had more extreme weather events in the last 10 years than we have in almost all the all the previous years put together. So in the pink or the blue. So we now have expectations for what the environment the farms have to function in. So one of our most extreme events in Spain was that we had, can I talk inches or millimetres of rainfall? Fantastic. So that's great. Thank you. So we can have, in our worst event in Spain, we had 8 inches of rain in an hour and 24 inches of rain, in 24 hours. So we lost a lot of crops and a lot of fields. So in short, we can extrapolate that we need our soils to be able to absorb 8 inches of rain in an hour. And we can go around the world and find examples of our soil types that are able to do that. So we have to change our farming to get the soils able to do that. We have been plagued by endlessly increasing the number of tractors in our fleet, and at the same time increasing the horsepower of those tractors. And that's partly self-indulgence because you've got to have a bigger tractor than the neighbour, and it's partly because the soils are just becoming harder and harder to work. So one of the pleasing points we reached last year was when we could actually, in renewing our fleet, we dropped off all the biggest tractors. And we now know we should have actually reduced the fleet on one of our UK farms. We should have not only dropped the big ones, we should have dropped the total number of tractors. So we've now got too many tractors and too many drivers. The ego thing played out there because they did go out and buy 2 of the biggest tractors they could, just because the neighbours had a bigger one. So we can reduce our capital cost of tractors, and we can reduce the amount of fuel we're using in our farming, and of course it also means we take the weight off the tractors we're using. Inputs, there's a reducing portfolio of agrochemicals that we can now use. So as a celery grower in Spain, we now have no herbicides that we're allowed to use after planting. We're about to have no insecticides available on our Spanish crops from about November onwards of this year. So these are like really major farming challenge changes that we've got to adopt to. And anyway, if you look at that chart I put up of the growth of our costs, it's our conclusion that we have to reduce the number of inputs we're buying. We need to be much more selective, and what we've understood is that if we can optimise our nutrition, and central to that will be applying much less nitrate and phosphate, then we can reduce the amount we need to spend on both herbicides and plant protection fungicides and insecticides. Water is perpetually scarce for us, particularly in Spain and Senegal, which makes it very expensive. And every time we save money, like less cultivations, less diesel, we reduce our carbon footprint. And our experience is every time you reduce your carbon footprint, you save money. So all of it puts together, if we can grow the same yield with less diesel, less tractors, less purchased inputs, we're going to have more profit. And finally, on the emissions context, 30% of UK emissions comes from the food system, and 44% of all of the food system emissions are domestic agriculture, and there's fertiliser further up as well. So and we're into these 3 areas of territory for our sustainability agenda, and actually it turns out, although we've addressed them as 3 separate work streams, it is of course one work stream. We've calculated our footprint, and if we look at the farming business as a whole, within the total group footprint, 75% of the farming emissions sit in diesel, fertiliser, water and some peat for propagation. So for us to make any impact on our footprint, we've got to deal with all of those. And if we deal with those at the rates we've calculated we can, we will have improved, assuming we still produce the same yields, we will have improved the group's net profitability by between 25 and 50%, depending on which year of our recent results you pick. So for us, this is a really big profit play. In a world where, actually, believe it or not, profit has been scarce. Just going to skip through some slides here. So I'm going to tell a story around one of our farms. This is 3,000 hectares of lowland black peat, some of the most fertile soils in Britain, probably amongst some of the most fertile in the world, and they've become a centre for the UK produce industry, partly because of their fertility, but also because they were so pliable. We could work them, it could pour with rain until 11 o'clock and we could be planting by 12 o'clock. So immensely forgiving, and over the years, as machinery had got bigger and the business had got bigger and there was less nous in it, probably, we'd abused the land with heavy machinery, with doing things at the wrong times. You have to harvest iceberg today, every day. You've just got to be out there. So we've made the farm significantly worse. We had ground that went impenetrably hard as soon as it got dry. In the winter, we had land that just slumped as soon as it got wet, became anaerobic. And you can see the iron appearing there, and the horse's head sized clods that would come up when we worked the land, which we then had to beat into submission with repeated rotary cultivations at huge expense in order to thrash out a seedbed that wasn't really particularly good at sustaining plants or seedlings. So that was, we were in the territory of the farm becoming unsuitable for the business it had supported for 50, 60 years. So something had to change, and we spent 3 years playing about with the principles of regenerative agriculture, and we were trying, it's embarrassing to say this now, we were trying to get the value of each of the principles of regenerative agriculture in their individual contribution. And then the penny dropped that the system only works when the whole system's working, and that's when we started to make some change. So we worked as hard as we could to express the principles, recognising that there were business practice constraints that stopped us, and also recognising that there was no way we were going to go cold turkey on this, because we couldn't afford to grow really high value salad and veg crops and not have a successful yield at the end. So we've gone step by step, gently does it, testing as we go. So this is like, I'm not sure whether the picture really sells this, but this is a major change in kind of structure that we've seen at depth. We've had soils now, the winter before last, we had double our normal rainfall. It just rained and rained and rained, and the soils eventually did slump a bit, but not until March. And up until that, we'd had fantastic porosity all the way through, and we now have some soils which stay in a much more even and consistent condition throughout a range of weather conditions. And at the risk of stating the obvious, it's kind of, I'm very nervous being stood here in Australia talking about this, because about a third of what we've learnt on regenerative agriculture and our learnings have come from Australia. So I wouldn't want you to think I was coming here to tell you what you already know how to do, but in order to make sure we've got a common understanding for a subsequent conversation, I wanted to be completely clear that our understanding of regenerative agriculture is expressed by this slide from an organisation called Understanding Ag, or closely associated with, for example, Gabe Brown, that regenerative agriculture is all about carbon and biology. We want to get photosynthesis, harvesting sunshine, turning it into carbon, pushing it out of the plant as root exudates to feed biology in the soil, which improves the structure and converts the mineral residues in the soil into plant available minerals and facilitates the absorption of those minerals in order to make the plant photosynthesize faster so that it can produce more exudates, feed more biology, and so on, in a wonderful virtuous circle. And the more we've learnt about this, the more we can understand how it is metabolically so much more effective that we can actually produce the same or higher yields on lower inputs. There is a wonderful developing science around this, and as I say, we've learnt as much from Australia as we have from anywhere else on all of that. We have 2 accelerators to our process, so we sort of know that if we just behave better to our soils within the principles of regenerative agriculture, that we will change our soils in the end. But as I said earlier, we want to change without customers noticing the difference, and we can't afford to lose any yield or we will go bankrupt very, very quickly. So we are using 2 accelerators to help us progress through the period of change. The first one is sap and tissue testing, and then trying to optimise the mineral nutrition of the plants to change the balance, replicating what we believe the biology will do for us when we've got the biology in place. The second one is a fast-track approach to getting the biology in place, and that's using a process or a composting technique called Johnson-Su. So anyone familiar with the work of David Johnson and his wife Wei Chang-Su? Brilliant. Do you want to come up here for a minute? Okay. All right. So David Johnson has produced this composting process. I don't think he's a professor, but he probably ought to be. So he's an American academic closely involved in agricultural research, and he's produced this process, which in his world is a 400-day process, and it's designed to create diversity. So typically in the UK, not just on our soils, but absolutely typically, through the repeated use of high levels of fertilisers, agrochemicals, lots of cultivation, what we've created is massive bacterial dominance of our soils. So we've killed the fungi that are less resilient to all the things I've just described, and we've also killed the protozoa, the nematodes, all the organisms that live on bacteria and fungi. So it's like taking the wolves out of Yellowstone or all the predators out of any environment you're familiar with. An ecosystem without predators doesn't really work. So what we're trying to recreate with Johnson-Su, we're using this microbial inoculant that comes from the Johnson-Su composting process, which is rich in protozoa, nematodes, lots and lots of fungi, so fungi that are missing, but also with the fungi diversity that really enriches the soil, and a much bigger bacterial diversity than we typically have in our soils. So we're aiming to make the soils really crowded with both abundance and diversity and a wide species mix. What we've found is that this abundance and diversity, when put together with root exudates, so mostly where we can in the absence of fertilisers, rewards the plant for increasing its root exudates. So, and maybe is switching on genes. It's having some sort of epigenetic effect. So we're able to see a difference in the plants that are growing where we've treated with Johnson-Su. And I'm telling this Johnson-Su story because I think we're feeling that Johnson-Su is a biological inoculant. It's something we apply to the soil at between 1 and 10 kilos a hectare. In other words, I don't think this is in any way a nutritional effect, but we're seeing yields increase by 20% and disease go down. So, and I'm also not saying do Johnson Su and don't do Regen Ag. The platform, the main things we're doing is changing our farming in line with the principles described by regenerative agriculture, but the accelerator in bringing the benefits of that to play is, amongst other things, Johnson Su. So just to look at that a bit more, right, how's this photo showing up? So here is a standard crop of red little gem, and on the right here is the same plants, same drilling date, same variety, treated with Johnson Su. And I hope from where you're sitting you can see that this group is slightly smaller and this group is bigger and redder. So these two are treated, those two aren't treated. So something in excess of 20% extra size for any given harvest date. And amazingly, they're both redder, and you can't see it in the photo, so please take my word for it, massively waxier leaves. So there's a whole new expression of wax on the leaves, which we think is taking the plant, showing the plant being moved through into the third level of John Kemp's plant health pyramid. So 20% large heads. This is no phosphate, no nitrogen. Okay, so and probably the more we reduce the fertiliser, the more effect we're getting from the Johnson Su. And as a by the by, actually I'll come to that in a moment. So I spoke there about the third level of John Kemp's plant pyramid, and I've already met, since I've been in Australia, lots of enthusiasts for John Kemp. So for those of you who are familiar with all this, I apologise, and for those of you who aren't, here's a quick starter on John Kemp's plant health pyramid. We're using this to support our analysis and response to our sap and tissue testing. So when you do a sap test, you get an Excel back on loads of detail on what's in your plant and what isn't, and that's great. But how do you respond? How do you interpret? And how do you choose what to do about it? So we use this. So the idea is, if you can get, if we can get the bottom levels of the pyramid sorted out, get your photosynthesis to happen quickly, and to get your protein synthesis to happen functionally, you're on the way to getting a healthy plant. We've discovered, for example, in our business that photosynthesis was frequently limited by magnesium and manganese deficiency. And it turned out, although we were putting them on, particularly magnesium, we weren't really recognising that as the plant grew, the biomass grew, and we needed to be putting more on to match the biomass of the plant and the growth it was about to complete. So a few basic things that we can now see signs in our plant sap analysis that photosynthesis is happening more completely. And a big one for us is to get to complete protein synthesis. So we have quite high natural nitrate availability on this farm from high organic matter soils. And we just assumed that our plants would always be bursting with nitrate, and it would be an endless problem that the cells were stretched and an ideal high nitrate sap for sap sucking insects. And what we discovered was that actually we were again deficient in particular magnesium, and that once we corrected the magnesium levels, we went from for example, in celery, we went from 60% of the nitrogen in a plant as nitrate to 10% of the nitrogen in a plant as nitrate. So we could reset the whole balance. And once you get nitrate right in a plant, you reduce the dilution of sugar content by all the water that's draws in by osmosis by that high salt nitrate. And all of a sudden, the sugar level in your plant is much better. So sap-sucking insects, I believe, someone's going to be equipped to tell me I'm wrong, but I think sap-sucking insects prefer high nitrate, low sugar. And that if you can get them get them trying to feed on something that's low nitrate, high protein, high sugar, that they usually can't survive. And which means they might individually survive, but worst case, they won't be able to breed. They just won't be functioning at a level where they can reproduce. And when you get into the upper levels, this is the John Kemp theory, that you start to produce more lipids, so potentially more waxes on the leaf of a little gem, for example, and ultimately more of these secondary metabolites, which is what makes plants not only unappealing but also resistant to insects. So we're using Johnson Su now to help us with that balanced nutrition, helping plants to absorb nutrients. So this is a potato crop shortly after planting, expressing 3 application rates of Johnson Su. So loosely, it's 1 kilo of compost translates to 100 litres of Johnson Su extract. So on the left is a 0 rate, no Johnson Su at all. Here is 200 litres a hectare of Johnson Su, and here is 400 litres a hectare of Johnson Su. So what we typically see then is, whether you're talking about a grain of rye or a grain of wheat treated with Johnson Su, you get firstly more roots. So you get an initial change in the partitioning of the plant's resources. So we get more roots, and then noticeably here, fantastic cascade of biology in the rhizosphere, which is helping the soil stick to the roots. So this lovely hairy finish. And in potatoes, what we're seeing, you can see even at 200 litres, we're getting more shoots per tuber. So again, a sort of change. And just to look a little more closely at that biology here, we're bizarrely excited by this. And again, looking at a bit later in the growth stage, here we go, 400 litres my side, 200 in the middle, 0 on the other side. So kind of, and I'm sorry, this was a sample of 3 from a whole field of 3 different treatments. So probably statistically not very good. And just to continue with the story, here's Johnson Su on some seeds untreated here. So this is interesting. Do you know what I mean? At a very simple level, it's intriguing, but we're very pleased with the results it's having on plants. Just to give another example, iceberg from the year before. Wasn't the first trial. The first trial, the colleagues went out to evaluate the trial, thinking it was just going to come for harvest. 50 hectares of iceberg. Unfortunately, and 2 planter widths of Johnson Su treated plants planted in the middle of the field. And unfortunately, the harvest crew had already found the trial and harvested it 3 days before the rest of the field. So, nice little story. And this was subsequent trials. We are getting higher yield, bigger heads, more even heads, but increased. We're finding, even where we have applied no phosphate, and maybe particularly where we've applied no phosphate, I don't completely know that yet, we're getting higher levels of P in the plant than we are where we're applying fertiliser. So we're changing maybe the availability, but we're also, I'm sure, the theory is aiding the uptake of the phosphate. And our soils are crammed full of phosphate, but we've still been applying a lot as part of what we do. On onions, we've definitely improved establishment. We've had the same yields out of onions without growing with Johnson Su, but with no fertiliser, as we do with a full fertiliser programme. And we've planted onions into fields we haven't used for 30 years because of white rot, and we found that yes, we've got white rot in the untreated, but we've got very, very little white rot in the Johnson Su treated plants. And I'm really optimistic that we're going to be able to use Johnson Su now to counteract some of our fusarium problems, purely on the basis that we know, very simplistically, fusarium is the pathogenic forms of fusarium are very poorly competitive, and if we can make our soils biologically crowded, I think there's a really good chance that both we strengthen the plant's defence system and leave no room for fusarium. Just a couple of pictures here. This would be the establishment process ahead of lettuce planting. So this combination through the cover crop, sometimes same day, sometimes the day before planting, followed by 1 rotary cultivation, then we're planting. Here's what's this is what's under the cover crop. It's not after the cultivation, this is through a spade. but an indication of sort of signs of soil life living on and around our roots. And then looking at the iceberg plants, roots under iceberg 7 days after planting, we're seeing this rapid, extra fast root growth, and then rapid colonisation of those roots by the soil biology. So yeah, more of the same really. Application of Johnson Su. Here we're putting some into row onto some existing established celery plants. Here we're applying as a jet on with a cereal grains. We now inoculate the grains directly, and on the right this is Johnson Su being applied to onion seed at drilling. And we use the same approach to potato planting. And here, this is the best yet. This is us, 5 kilos of compost, sieved compost. We add a litre of molasses and a litre of fish oil to create a sticky paste, tip it into the cement mixer with the corn, and within about 5 or 10 minutes, you've got a properly inoculated corn, and it's a sort of incredibly cheap process. So just to reiterate, 3 slides on what we're trying to do. Here's us. Existing thing. This is our soil food web as it stands. So lots and lots of bacteria, virtually no fungi, none of these third and fourth trophic levels, and then we're taking a Johnson Su. We know we can check now that we've got fungi, we've got nematodes, we've got protozoa, and we can throw that into the soil. So what we want is a protozoa eating a bacteria. So apparently one protozoa, I don't know how anyone knows this, but one protozoa eats 10,000 bacteria a day. I hope, how they got to that, I don't know. And a protozoa is 30 to 1 carbon to nitrogen, bacteria is 5 to 1. So when a protozoa eats 6 bacteria, it's got enough carbon, but it's got 5 waste nitrogen. So when we get one thing eating another, nematodes are 100 to 1 carbon to nitrogen. So when they eat bacteria, they spit out even more nitrogen. So this is, I'm using nitrogen as an example. It could be magnesium or calcium or whatever. Whatever's coming out of the carbon, of the biomass, we're starting to cycle when they all eat each other. And practically that looks like this. So we can now see, I don't know how we're going to measure this in a sort of empirical fashion that everyone wants to measure everything these days. But we can now go to our soils and we can see the difference in structure, we can feel the difference in structure, and we can smell the difference in our soils. So those as practical measures are really useful and encouraging. And it's, we've had some frustrating periods in transition, but it's one of the biggest excitements is now going to fields with colleagues and seeing them once again being amazed by what they're seeing. So it still freaks us out a bit and gets us excited when we see springtails, millipedes, centipedes, the visible signs of life in the soil, earthworms at levels we haven't been seeing for years. So we've got tractor drivers now saying, the land isn't taking anything like the work that it took to break down before. The tractor isn't working, pulling whatever implement the way it was before. One of my colleagues who has joined us recently, he'd been farming on rented land over a sort of 250-mile radius around us for 30 years, and he arrived on the farm and he said he's never seen life in the soils like we're seeing now in any of the farming he's done across a very hard farmed area. So we're trying to make this ecosystem work. Fundamentally though, I don't want to say our life is all about Johnson Su. Johnson Su is just an accelerator we're applying to what we're doing anyway. The really hard yards is growing cover crops, making them as multi-species as possible, and using them to keep the soil covered. So, this is all stuff we're doing, minimising soil disturbance. It's not a done deal. So we've got 11 farming operations, and we're sort of into this halfway with 2 or 3 of them, and we've got 1 operation that's into it further. But even within that, I've got colleagues who are still given half a chance, burying whatever implement they're pulling and ripping it up as deep as they can. So what am I trying to say? The mindset battle that comes with change is, I think, the biggest part of it all. That we're all in farming systems where we're naturally risk adverse. No one wants to have a crop failure. No one wants to be responsible for a crop failure, either in kind of business sense or with neighbours looking over the fence at them. And we also grow high value crops where the risk of failure is intolerable financially. So we would all tend to keep doing what we've done. We keep applying the same stuff from the bag and the same stuff from the bottle. And we know what it does, and we're in safe territory. So how we accommodate risk in transition is interesting, and we've kind of taken the pressure off by saying we're just going to go step by step, slowly, no cold turkey, and that's how we're going about it. Shall I stop there? I feel as though I've been talking for ages.
Yep, go for it.